If you want higher grades in physics, you need more than just knowledge. You need a disciplined method for answering questions. This video explains stage one of the forces approach, the essential first step that separates average answers from high scoring ones. Apply this method correctly and you'll start to gain marks that most students consistently miss. Hi everyone, this is the Grade Booster Pack, which is part of Grade A Physics. This is designed to boost your physics A-level grade, to push it up either from a C to an A, or possibly even to an A star. So the key thing here is to realize that students lose marks because of lots of small mistakes. That's a really fundamental thing. So it's extremely rare that a student will have lost lots of marks on a single question. That is entirely possible, but they tend to lose marks throughout the paper. So they might forget a unit, they might round incorrectly or misunderstand the prefix or give a vague explanation, etc, etc. So the accumulation of these marks makes the difference. So rather than thinking you've got to be an absolute genius to push your grade up to an A or an A star, although that probably helps, you don't have to be a genius. You just need to get a few extra marks on every question per paper. For example, so on one paper, on average, this varies obviously year to year, paper to paper, but on average, to push your C up to a grade A is 10 to 20 marks per paper. So that is a lot of marks, but it's 1 or 2 marks on every question. Similarly, to go from a B to an A star will be 10 to 15 marks on average per paper. So this is achievable. This is very much achievable, but you have to have a strategy. And very often students think they'll just do, quote, more work or be better at physics somehow, but having a strategy really helps. So this is the forces strategy. This breaks it down into 5 categories. So the foundations we're going to go through, that's what this video is about. There are 4 other videos I recommend you watch, which relate to the other 4 stages. If you can really understand how these skills are assessed and how these marks can be guaranteed, then you'll really start to make a difference. Obviously, this will help you understand the physics and the exam skills and also a good revision strategies as well. But this hopefully helps you view and visualize an overall approach to revising and to answering questions in exams. So this is step 1. This is the F for foundations. So this is on the basics, on accuracy and getting the basics right. So typically in an exam paper, a lot of marks are missed just because students don't write the correct units, or they've misunderstood the prefixes, or they've either selected the wrong formula or don't know what the symbols mean, or written down the formula or rearranged it incorrectly. Rounding errors, significant figures. Dimensional mistakes, that's using the wrong quantity or mixing quantities and units incorrectly. So these are the basics. This is really, really important that you get this right. And the typical examiner's comments are that students very often understand the physics, but they don't express it or manipulate the maths correctly, and they lose approximately 10% of their marks just on making simple mistakes. And a lot of students are aware of that. I've seen over the years many students say, I just made lots of simple mistakes. So this is what you need to stop doing. So, for example, always write the formula. That's so important. I tell my students this all the time. You've got to write the formula. It helps you in your answer. It also helps the examiner give you marks even if you get the wrong answer. Check the significant figures. This is very important. So look at the precision of the data you're given, and that would be the guideline. So if you're given numbers with 2 or 3 significant figures, then you should be writing your answer to 2 or 3 significant figures. Always write the units. This is such a frustrating thing for students that they miss out on these easy marks because they haven't written the units. Read the question carefully. Now, this is a really important thing throughout all 5 stages. Use the information given. Why have you been given some information? Why have you been told something? And this also relates to multiple stage questions. So if in part A they ask you to calculate the voltage, and then in part B you don't understand the question, well, why have they asked you to calculate the voltage? Show you're working clearly. If it's not clear, you will lose marks. You might lose all the marks. And your general check for every calculation is Have you written the correct unit? And is it a sensible size? Does it make sense? I was marking a test the other day when a student was working out the temperature of a gas in a simple container, and they got, I think, 3 times 10 to the 26 Kelvin, and they wrote it down. Well, that's just obviously wrong. So you need to look at the answer and see, and ask yourself, does it make sense? And if it doesn't, you've probably made a mistake. So let's look at an example of this. So I've well, this is an exam question, but I've created a student answer, and we're going to look at where the marks have been lost. Now, some of these are pretty obvious, some maybe less so. If you want to, you could pause the video at this point and answer the question. That might be a good idea, but I'm going to give you the answer. This is like an incorrect answer. So what I want you to do now, actually, you could pause the video again and look through this and mark it, allocate the marks, identify how many marks are lost and why at each stage. So I think that's a valuable exercise for you to do. Let's have a look at where the marks have been lost. So there's a whole range of things they've done wrong here. So let's have a look. So A equals pi r squared. So that's great. So they've written the formula, but that's a GCSE formula, so you wouldn't get any marks for that. We've got 0.5 millimeters. Right, this is so common. And even students who are doing maths A-level or even further maths make this mistake. So that's the diameter. We want the radius. We need to divide it by 2. This is millimeters. We always work with meters, so they've forgotten to divide by 1,000. So that's already incorrect. And they've got an answer here, too many significant figures. A lot of students write this. This is really bad practice. They'll write an answer and then they'll continue a separate calculation with an equal sign. That's fundamentally nonsense. That doesn't make any sense. We haven't identified what we're trying to find. And if we follow this logically, we're saying that the area is equal to this answer here, which is not true. We're trying to find the stress. So we should write a separate line with the formula and then write F over A. But they've made another mistake. They haven't changed mass into weight. Again, very, very common mistake. So they've got a value here, which is obviously incorrect. The stress in the wire, we should look at that, or the student should look at that and think that is way too small. Stress, you should be familiar with, typically is megapascals, and they haven't written the units pascals as well. So lots and lots of mistakes there. Would they get any marks for that? Probably not. They might get a mark maybe if it's the examiner's feeling generous, but probably not. Part B, so what have we got? 2 marks, calculate the strain. So they haven't identified what they're finding, but it's only asking for the strain, so that's not too significant. They haven't written the formula, but it's quite a simple one. They've used 1 millimeter divided by 2, so again, millimeters into meters, so they've lost a mark there. Again, we should be thinking 0.5 for strain, that's 50%. So that means under this situation, the length of the wire is now half as long again. That should ring alarm bells. You should be thinking, that doesn't sound right. Typically, the strain would be 10 to the minus 3 or 10 to the minus 4. So that is incorrect. They might get a mark for that. A strict examiner might give them nothing for that. For the Young modulus, they've written stress over strain, which is good. And they've used their value, even though that's incorrect, divided by their previous incorrect value. So even though this is definitely wrong and there's too many significant figures and they haven't written the units of pascals, they might get a mark for this, possibly even 2 if the mark scheme was not insisting on the units. So even though this is fundamentally wrong, and again that should ring out alarm bells, a Young modulus of 10 is way too small. We'd expect gigapascals, 10 to the 9. The fact that they have written out the formula and we've got error carried forward, they've used their incorrect values, means they could potentially get 2 marks there, but possibly only 1 mark. So they've lost out of 3, 4, 5, 6, 7, they've lost at least 4 marks, possibly 5 or 6 marks. So lots and lots of issues there. Let's have a look at the correct answer. So here we go. Calculate the stress in the wire, so separate calculations. We need to calculate the area. Area is pi r squared. We've divided by 2 and we've divided by 1,000 to get the correct value of area. So this is the type of value we would expect. If it's a fairly thin wire, 10 to the minus 7 sounds about right. We should feel confident with that. We've got the units, that would be 1 mark for that. The second mark would be to calculate weight, write the formula, m times g. We've got 39.2 newtons with the units, that's fine. So even though newtons and meters squared are probably not necessary here, it's good practice. And it also helps identify what the quantity is if you haven't labelled what it is on the left-hand side. Stress is F over A, so we're using our values here. A correct calculator technique would give you a very large value of stress. So we've got 2 significant figures, which is the same as the sig figs in the question. We've got a capital P, not little p, pascals, and we have standard form. For part B, we've written out the formula, good practice. We've changed 1 millimeter into meters, and we've got an expected value, 10 to the minus 4, a really small value. That sounds about right. No units for strain. And the Young modulus, we've written the formula, and we've got our values. So we've got 2 10 to the 8 divided by this value here. We would expect to get a really large value in pascals again. So really important to show all your working clearly, including the formula, to make sure you get ECF, error carried forward. That is such a powerful way to get absolutely every single mark you can in the exam. Even if you get part A and part B incorrect, you can get full marks for part C. What I recommend you do now is go to the Grade Booster booklet and work through the Part 1 Foundations questions. So there are 5 questions taken from a range of Year 1 physics topics. So you can use the formula booklet for your specification. That's something that you need to get really, really confident with. Have a go at these questions and then check with the mark scheme at the end of the booklet. I'll see you in Part 2.